This is an R tutorial. Got 2 minutes? Learn some statistical programming in R. It's easy, free, and fun. This tutorial, how to test for correlation between two variables in R. This is a fancy mathematical tutorial. If you don't know and don't care what a correlation coefficient is, you probably want to skip this one. But if you like math, and I know you do, then gather round, children, gather round, and listen while I tell you an ages-old tale of statistical lore from days of yore. In olden days, statisticians liked to calculate or measure associations between two variables. Let's load the example MTCars data frame, but you can load your own. Here's what MTCars looks like. Once upon a time, a wild old statistician wanted to determine the relationship between miles per gallon and horsepower. Here's the miles per gallon and horsepower columns of the MTCars data frame. Our hero wanted to calculate what these ancient statisticians like to call a Pearson's product moment correlation coefficient. Now remember, those were the days of yore, so they had to do fancy mathematics to test the association between two sets of numbers. You live in the future with the R statistical programming language, so you can just plop these two things inside of the core function, separating them by a comma, and you'll get the correlation coefficient right there. Wow! It looks like it's a negative association between horsepower and miles per gallon. In other words, a car's miles per gallon go up, and the horsepower tends to go down. Wow! If you want to save a little typing, you can also just restrict the MTCars data frame to just the horsepower and MPG columns and paste that directly into the core function. If you want to calculate the correlation coefficient of every variable in this dataset against every other variable in this dataset, you can put the entire data frame in the core function like this, and look at those results. So for example, the horsepower and SIL column have a very high correlation coefficient, 0.8324. Remember, the strongest correlation you can have is either a 1 or a negative 1. But it looks like the horsepower and the number of gears has a pretty weak correlation of negative 0.1257. Note that in addition to calculating a Pearson correlation coefficient, which is the default if you don't specify a method, you can also calculate a Kendall or Spearman correlation coefficient by changing the method to quote Kendall quote or quote Spearman quote. Or you can just keep kissing frogs and hope for the best. This has been a work of Happily Ever After.